Welcome to my channel, DNA.12 Education. Hello students, welcome again to my channel, DNA.12 Education. Students, today our topic is integration. A level map for Cambridge International Integration Power Rule, Part 1. Okay, students, integration is a way of adding slices to find the whole. Integration can be used to find areas, volume, center points, and many useful things. Math level, integration, power rule, part 1. Okay, students, understanding integrations. Okay, students, today I'm going to show you how to do the basic integration with the basic rule, some powers or 3. Let me show you how to do it. Students, understanding integration is very easy. Integration is the reverse of differentiation. However, if y equals 7x, dy over dx equals 7. If y equals 7x plus 5, dy over dx equals 7 as well. And if y equals 7x minus 3, dy over dx equals to 7 as well. So, integral of 7 can be y equals 7x, y equals 7x plus 5, or y equals 7x minus 3. For these reasons, when we integrate, we have to add a constant. So the integral of 7 is 7x plus c, where c is a constant, right? Integration is the reverse of differentiation. I'll show you the way to prove that integration is the reverse of differentiation. Y equals 7x. When we differentiate this function, dy over dx equals to 7. We can simplify this function by cross multiply. So dy equals 7 dx. Integration is the reverse of differentiation. We can say that differentiation is anti of integration, or integration is anti of differentiation. Now we can put the symbol of integral for the both sides, left and right. This is the symbol of the integration. When we put the symbol of integration left and right, integral of differentiation is y, right? integral is anti of differentiation. Is it? So integral of differentiation is y, right? So we can write, for the right side is integration of 7 dx. So it's proven that integration is the reverse of differentiation. Is it clear to everyone? Integrating is the opposite of taking the derivative. Integrating is the opposite of taking the derivative. Means integrating gets back up to the original function. Integrating gets back up to the original function. When we have y equal integral of 7 dx, by using the technique of integral, we will find that y is 7x plus c. So it's proven that integration is the reverse of differentiation. Is it clear to everyone? So when we have y equals 7x and we differentiate the function of 7x, we'll find the differentiation of 7x is 7. Integrating gets back up to the original function. So when we integrate 7, we will find that integral of 7 is 7x. So that's why integrating gets back up to the original function. Right? So that's very clear. Integrating is the opposite of taking the derivative. Integrating gets back up to the original function. So that's why integration is the reverse of differentiation. Is it clear, everyone? Okay, good. Integration by using power rule. Integration. How to integrate? What's the technique? Okay, so let me show you how to do it. To integrate a term, increase its power by 1 and divide by this figure with respect to x. The integration technique is to integrate a term, increase its power by 1 and divide by this figure with respect to x. This is the formula. How to write this one? Integral of x to the power of n is x to the power of n raised by 1 over the power raised by 1 plus c. Integral of x to the power of n is x to the power of n raised by 1 over that power raised by 1 plus c. Is it clear to everyone? This is the concept of the integration by using power rule. This concept or this formula will be satisfied when n is not 1. Okay, so once again, integral of x to the power of n is x to the power of n raised by 1 over the power raised by 1 plus c when n is not 1. That's very easy, right? So what do you think about this one, students? This formula is very easy. Okay, students. Now we're going to understand this concept by doing several examples. Number 1, integrate y equal integral x squared plus 2x plus 1 dx. This is our concept, right? Integral of x to the power of n dx is x to the power of n raised by 1 over the power raised by 1 plus c. Integral x squared plus 2x plus 1 dx, we can simplify to be x squared plus 2x to the power of 1 plus 1x to the power of 0 dx. Students, to make sure that everything this function clear and to help you to solve this one very, very fast, we have to understand that 2x actually is 2x to the power of 1. Right? And 1 as a constant, we can write as 1x to the power of 0. Is right? So that's why we got this function. Clear to everyone? Next, by using the technique of the integral, okay, this is the technique of the integration. We can apply to integrate this function. It's very easy, right? Okay. The power raised by 1. Okay, students, the power will be raised by 1. For the x squared, raised by 1. Okay? And then over by the power raised by 1. Okay? Done for x squared. And then we can apply to the 2x again. 2x, the power of 1, raised by 1. And then over by the power raised by 1. And we can apply this concept again to x to the power of 0. 0 raised by 1. And over by the power raised by 1. Right? That's very easy. So we can simplify this equation. It will be x cubed divided by 3 plus 2x squared over 2 plus 1x to the power of 1 over 1 plus c. We can simplify this one again, cancel, cancel. And finally, we got x cubed over 3 plus x squared plus x plus constant. It's very easy, right? Okay, students, now we have a new formula to simplify the integration of the function. Integral k dx equals kx plus c. Once again, integral k dx equals kx plus c. Okay, students, remember this formula. That's very easy, right? Okay, students, I give you the next example. Integrate y equals integral 1 over x squared dx. Once again, this is the concept of the integration. Integral of x to the power of n dx equals x to the power n raised by 1 over raised by 1, the power raised by 1 plus c. Okay. Now we have the function integral 1 over x squared dx. Students, we have to change the form of this function to make it simple to be integral x to the power minus 2 dx. Students, I give tips 1 for you. Avoid the fraction form before integrating the function. Once again, avoid the fraction form before integrating the function. Means change all the position of the function to be numerator. Okay, so you have to avoid the fraction form. Why you have to avoid the fraction form? To simplify the equation. Okay, so when we have the function like this, okay, when you have the function like this, so this function is adjustable to the formula, right? Okay, next, the integration techniques. The integral of x power minus 2 dx is x to the power minus 2 raised by 1, okay, and over to the power raised by 1. Is it? So we can simplify that x to the power minus 1 over minus 1 plus c. Or we can find the final answer is minus 1 over x plus c. That's very easy. Okay, next, student. The next example. Integrate. Y equal integral 1 over x plus 5 dx. Integral 1 over x plus 5 dx. Okay, once again, I want to give you this one. Make sure remember this concept of the integration. Integral 1 over x plus 5 dx. Sorry, this one. Integral 1 over x plus 5 dx. We can simplify as integral x to the power minus 1 plus 5 dx. Tips for you, avoid the fraction form before integrating the function. So means, by using the formula, x to the power minus 1 plus 1 over minus 1 plus 1 plus 5x plus c. You should remember this concept, right? integral k dx equal to kx plus c, right? But we have a new form of the integral, right? So we have to remember this one. X to the power minus 1 plus 1 over minus 1 plus 1 is ln absolute of x. Once again, ln absolute value of x plus 5x plus c. So you have to remember this one. Integral 1 over x dx equal ln absolute value of x plus c. ln is natural log. ln is natural log. Okay, the next example. Integrate 3 root of x minus 2x cubed plus 4 x cubed to 5th root dx. Once again, integral 3 root of x minus 2x cubed plus 4x cubed root of 5th dx. Tips for you. Change the power to the fraction form before integrating the function. Change the power to the fraction form before integrating the function. So integral 3 root of x minus 2x cubed plus 4x cubed root of 5 dx equals to integral 3x to the power of half minus 2x cubed plus 4x to the power 3 over 5 dx. Remember this exponent concept. A to the power of n over n equal a to the power of n root of m. So when we have x cubed root of 5, we can simplify as x to the power 3 over 5. Is it clear to everyone? And then what about root of x? Root of x is x to the power 1 over 2. 1 of square root. Is it clear to you, everyone? That's pretty clear to you, right? Next. So we can simplify, okay, the integration. Look at the concept. Remember the concept. Try to remember. 3 times x to the power of half raised by 1. Okay, and then over plus a half plus 1. Then 2x cubed raised by 1. And over to the power raised by 1. And then plus 4x to the power 3 over 5 raised by 1, right? over the power raised by 1 plus c. It's very easy, right? So we can simplify 3x to the power 3 over 2 over 3 over 2 minus 2x to the power 4 over 4 plus 4x to the power a over 5 over a over 5 plus c. That's very simple, right? Okay, now we have the simplest one. Okay, 3 over 3 over 2. 3 divided by 3 over 2. We got 2. Right? This one, 2 and 4 cancel. We got 2. And 4 divided by a over 5, we will find 5 over 2. That's very easy, right? So the final answer is 2x to the power 3 half minus a half x to the power 4 plus 5 half x to the power 8 over 5 plus c. That's very easy, right? That's the integration of power rule. Okay, students, to make sure this method is clear for you, at the end of this video, I'll give you 3 exercises to do. Good luck!